Hello, 8th grade Bobcat. So welcome back. A couple days ago, we talked about Newton's first law, and we set up our notebook and added this little blurb of notes on Newton's first law. Today, you guys are going to add Newton's second law. So what you saw and or demonstrated in class today was 3 labs that show you different aspects of Newton's second law. The main thing that governs Newton's second law is this equation right here. So force equals mass times acceleration. So we'll talk about that. This is our abbreviation. So for force, we're going to abbreviate force with a capital F is equal to mass, a lowercase m, times acceleration, a lowercase a. We can also write this out if you guys have ever used one of these little pyramids to help you with your math. You guys can see force is going to go above mass times acceleration. So you guys can kind of use this triangle to help you figure out how to solve problems with that, which you'll do a little bit later in this unit. Okay, so today you guys did 3 labs. You guys did the race car ramp, which was lab C. You guys did the softball wrecking ball, and then you guys did the craters. So I'm going to talk about those to an extent, and I'm also going to talk about some other examples to help demonstrate these. So let's talk about our first relationship here. So as our mass increases, our force is going to increase as well. So if we're looking at part A, the crater lab, the more massive, or the heavier, if you will, the craters are, the bigger force they left on the ground or on the surface of the planet. Okay, so that one's pretty easy to demonstrate. If we looked, for instance, at this one, as acceleration increases, force increases. So let's talk about that really quick. A big misconception is that anywhere in space has no gravity. Okay, so that's actually not true. If we look at a planet that's much larger than Earth, for instance, Jupiter, Jupiter actually has a higher gravity than Earth. So if we were to drop something, we're going to have a higher acceleration. Therefore, it's going to hit the ground with more force. So we can use the same analogy of craters, but in that instance, we're going to use the same size ball, but a higher acceleration due to gravity. Okay, and that would leave us with a higher force. Okay. Also, if we were to say push something harder, like maybe you guys are pushing a shopping cart at a wall. Okay, if you guys have the same size shopping cart that you push every time, and the first time you push it very lightly, it's not going to hit the wall with much force. But if you increase how hard you push it, or you increase the acceleration, it's going to have more force when it collides with the wall. Okay. Finally, we have as mass increases, acceleration decreases. So we can look at this one with like the crane, for instance. So what you had is with the softball crane, you dropped it from the same height every time. So basically you had the same force hitting a different ball every time. But the heavier the ball got, the less they accelerated. So if you were using like a ping pong ball, which has a really low mass, and you hit it with the force of the softball, it's going to accelerate really fast. Okay. However, if you increase your mass and use maybe a shot put, which is a pretty heavy ball, and you hit it with that softball, you're going to see a decrease in acceleration. It's not going to go very far from that force of the softball. Okay, so these kind of explain Newton's second law. Later you guys will do a little worksheet on Newton's second law, and I'll explain this pyramid a little bit better to you guys. If you have any questions, please let me know. If not, I will talk to you later. Bye.